Good afternoon here in India. It is a great pleasure for having been invited to deliver this keynote presentation on resilient manufacturing systems. So efficiency alone is no longer something which holds a strategic component, which holds for strategic priority. Now, today there are multiple shocks which are present in the volatility of the supply chain system and the cost, which is inflammatory. There is no certainty on the cost, which is dynamically changing every day because of tariffs. It could be because of multiple factors, because the cost is a more dynamic factor which has many parameters controlling it. Then there is of course, technology is also not constant. The technology is also rapidly changing. There are multiple breakthroughs coming in, and so the processes, methods, the materials we are using, and the machines that we are going to use for manufacturing systems, they keep on or are all evolving. So when in a multiple, when changes are multidimensional, basically the volatility and the dynamics of the manufacturing systems is become more multidimensional and with many parameters controlling. So now efficiency is no longer something which is a constraint. True manufacturing resilience is not invoked after its failure. That means from reactive to proactive, we have to look at it. It is designed into the system. That means the systems have to be designed such that they are able to adjust, adapt, and then mitigate the risk, even if there are any small known risks which are there in the system. They have to adjust. It could be cost, it could be technology. That means a particular system which is being manufactured on a particular system, on a particular material, on a particular machine should be immediately able to adapt to a new environment. That means a new machine, new material, and to the new methodology of manufacturing. The same thing. So now the three parameters which are very prominent, which this my research proposes, is from precision, intelligence, and decision making. So these are three outcomes that what we have observed from the exhaustive literature studies we have seen. So resilience have to be built into the system. That means designed into the system from three independent constructs. How these independent how do we build these resilience into a, that means enhance the resilience of a manufacturing system, is what we will study in the next few slides. So resilience is defined as a designed in capability. Resilience means it is not an afterthought. It is a pre-thought, a pre-existing parameter that is built into the system in the initial stage itself. So the PID framework means what we call, just now what I explained, the three fundamental constructs that we are proposing is precision, intelligence, and decisions into the frameworks. That means the systems have to be precise, the systems have to be intelligent, the systems have to be capable of making decisions. Now, what we call about the precision is the foundational operational stability. Precision means what the purpose which is serving and what we require. So that has to be very solid and it should be stable. Now, intelligence means sense of making. That means in the environment, in the production environment or in a manufacturing environment, we should be able to see, we should be able to sense, we should be able to collect, gather data. So that means the system have to be responsive. There is some activity going on, some operations which is being done. So the moment when some operation has to be done, has been done, there will be data generated. Once the data is generated, we should be able to sense it. Then we should be able to gather it. Then we should be able to collectively tabulate it or into a structured usable format. It has to be into a database. Now, how decision making has to come? The decision making has to come, which is based on the evidence. What is evidence? The database which is already created. So the data has to feed into the decision making systems, and it has to become evidence in action. So the next action should be based on the live data which is connected. Now, the sustainability alignment framework, what we do on Monday. Robustness is not alone. Robustness means it is not in isolation. Robustness comes with four operational dimensions. What are these robustness? Robustness, resistance to disruptions, capacity of a system to withstand any shocks without any functional degradation. Redundancy means ability to back up resources and deliberately stack them to give options under the stress. That means in a very critical moment, we should be having a clear options available with us. Then we can make better decisions. Which are the option 1, option 2, option 3, like that. We should be having choices there. So the matrix or the array of choices should be available for us. Then flexibility. Flexibility means the capacity to reconfigure. That means production environments, then the bends or the breaking in the lines. So whenever there is a disruptions, whenever there is a it could be in the supply chain, or it could be in the technology front, or it could be in the cost front as well. So if there should be flexibility for us to switch over between the options which are available for us. That means it could be machine, it could be material, it could be design, product design, or the application, any of them. So we should be having ample flexibility there. So the moment you increase flexibility in the design, that means the system will become more robust. Then the most critical one is the agility, the speed of recovery and adaptation. So this is again speed of recovery and adaptation. It is a dynamic capability layer that turns the disruptions into a learning environment. That means whenever there is a disruption, whenever there is an issue whenever there is a risk which penetrates into the system, the most important thing is we should be able to learn from the system, learn from the issues, why it occurred, root cause we should know. Then what is the corrective action we are going to do, whether there is a planned remedy available for us. The surprises will be catastrophic when we don't have a pre-configured remedy for it. So the precision intelligence design framework, PID framework means it means data-driven decision making to intelligence. Intelligence is again a capability. Then the precision, what we want. Precision is the purpose for what the particular manufacturing component or the system is being built. So when we are able to integrate all of these things, that means data-driven decision making, intelligence into the system, and the precision, then it will be designed in. Resilience will be designed into the system itself. So the framework is, the first framework, let us look at precision. What we are talking about, the precision is a disciplined management of process parameters. For every processing, there will be a set of parameters which are dependent and independent parameters. One set of independent parameters will be there and one set of dependent parameters is there. So how these parameters are related to each other, that depends on the governing equation or the processing model that we are using. So to achieve a consistent and repeatable output that meets a defined product quality. When I say defined, it is again AQL, acceptable quality level and performance specifications. So there will be predefined threshold what we are expecting some quality and some performance standard specifications. So it will be more qualifying in nature. So what we are talking about precision here is, by definition, is process variability is the primary source of quality failures, rework, production interruptions, all of which erode the total capability of the system. High capability systems generate fewer quality losses and maintain predictable output in varying demand. As long as a system is predictable, it is under control. How precision actually earns in its place in resilience? Precision, again, when we want to put it into the statistical perspective, it is process capability management. Capability includes qualifying relationships between the process variability and the specification limits, enabling proactive intervention before non-conformations. Then the second thing is, a precision is controlled. A precision earns its place in a resilience is because of tolerance engineering. That means we should be able, every system had to be engineered with a systematic allocation of dimensional tolerances across the components, across the assemblies, and including processes I am talking, to ensure functional performance under worst case stack up conditions. Now, we will look at the process capability control. That means in process control. That means it could be the real-time measurement feedback systems which detect and direct deviations at the particular point of time. It could be the run out chart for minimizing. That means only it is qualifying in nature. Now, the underlying the most core part of the precision is the toolings and fixtures and integrity of those. When I say integrity, it should be calibrated. So the tooling degradation is the primary source of quality variation in machining, forming, and in discipline behind the capability. That means the core part of the tooling means how reliable is your tooling that we are using for making any manufacturing processes. So the core part of all these tools have to be calibrated, and they should be well maintained. And the reliability of this tooling system is what will be the defining aspect of a precision that we are talking. Now, the second part is the intelligence part, which is something which makes sense out of the complexities in the organization capability to collect the data. See, data is anyway going to be generated in any process. Whenever you want to do any processing, immediately data will be started to generated. Immediately data generation happens. It is a ubiquitous thing which anyway will be happening. Now the question is, how are you going to gather this data? How are you going to precisely collect this data, integrate that into data, and then make some sense, interpret that operational data, revealing if you are able to do these three, that means collect, integrate, and interpret, then you will be able to look at some actionable patterns in that, and then some based on that patterns, you will be able to make some informed decisions. The value lies not in the data volume per se. Data will be very limited. Sometimes the data will be very large set of data will be generated. But the real capacity is how to extract that and process that and to make into actionable insights from complex, high-dimensional operational signals requiring both technical infrastructure, and that means when I say technical infrastructure, it is the sensors, it could be the data processing equipments, and then human interpretative capabilities. So ultimately, any data which is generated, it is collected, it is collated, and then it is processed. ultimately, to make some inferences, you still need intelligence, human capability there. Now, when I say intelligence, the most prominent factors of intelligence is anticipation over response. Detect precursors not in the aftermath, not afterwards, not as reactive type. It should be in the as a precursors. Predict what are these precursors normally, which is very typical, or predictive maintenance. All systems have to be, including the tooling systems, have to be predictively maintained. That means every system should be prepared for the processing. Then process analytics and anomaly detections. Then the process have to be observed. We should know how the processing should, before a process really happens or a process is actually done. We should know what anomalies can happen. Then we should be well prepared for any untoward situation. If A happens, then what is the remedy? If B happens, then what is the remedy? If, like that, you should have all known issues that are probable or likely, and then what are the remedies? That matrix should be readily available. Then demand and supply chain. See, demand and supply chain should be again predictable. So what issues, what signals, because demand and supply, though they are external to the manufacturing processes, you will have some signals. You will have some sort
Sorry
of.
to interrupt you, sir.
Yeah.
Your allotted time has been running out. Kindly conclude your presentation, sir.
Okay. So we should the demand and supply should also be in the precursor part, and then the digital twin. That means if you are in the digital twin, means example, it could be simulated, and then we should know the solutions which are defined. So let me come to the conclusion part. So let me, because of the time, I am just concluding. So the capacity to be simultaneously precise, intelligence, and decisively data-driven will define the boundaries between organizations which merely survive uncertainties and those that transform into sustained competitive advantage. So the difference between those which will sustain in the business and which will struggle with the uncertainties is the preparation, how systems are prepared for that. That means, again, PID concept: precise, intelligence, and decisively data driven systems.